Hello, physics, wave nature of light, double slit experiment. And the problem is the light of 480 nanometer in air falls on two slits 6.0 into 10 power minus 2 millimeter apart. Two slits have this separation. The slits are immersed in water, as is the viewing screen is 40.0 centimeter away. How far apart the fringes on the screen? So this double slit experiment is in water. So this is a slit, this is second slit, this is screen, this is the source of light, this is the one ray, it goes like this one, and this one, and this one. This is the center, and this is Y. This separation is L, and this distance is D. This distance is D, this is separation, this angle is theta. And everything is in water. In water. So we have to find the separation, the fringes. So wavelength, the lambda change due to water is lambda W. Lambda W is equal to lambda air over N water. Air is 480 nanometer, 10 power minus 9 meter, divided by refractive index of water, which is 1.33, and this comes to be 361, 10 power minus 9 meter, equation 1. Then for constructive interference, so d sine of theta is equal to n lambda. So n lambda in this case is lambda w. So n is equal to 0, 1, 2, 3. This is equation 1. And for the location of the fringe, on the screen, so is y. Y is equal to L. So this is y and this is L. So this angle L tangent of theta. This is equation 2. Then small angle approximation we will use. Approximation theta in radian. Then tangent of theta is equal to sine of theta. If this is the case, then equation 2 will be y is equal to L sine of theta. Then equation 1, we will use this one. So this will be y is equal to L, and sine theta is n lambda water over n is a number, and this is a refractive index, and then is a number over d. This is equation number 3. So If the adjacent fringe, so adjacent fringe and delta m is equal to 1, so that means y2 minus y1 is equal to delta y, and n is equal to 2, n is equal to 1 in one case and two case. So delta y is equal to n no delta n L lambda W over T. Delta N. Delta N is 1 and L is 40, this one, 40 centimeter, 10 power, a meter, zero point 0.4 meter, and lambda is water. Water is a 361, 10 power minus 9 meter, and D, separation, is 6.0 into 10 to the power minus 5 meter. So this will give us the separation, which is equal to 2.41 into 10 power minus 3 meters, or we can say, so delta y, the separation is 2.41 millimeters. So this is the answer of this question. So 480 and air, so then is water. So what will be the change in separation of the fringes?